Hello everybody. We're going to be looking at 1.4 day 1 using the definitions of the trigonometric functions. Go ahead and write down the title and go ahead and write down the date. You don't need to put your name on there, just title and date are fine. What we're looking at here are the reciprocal identities. And if you want to, it's probably a good idea to jot these down in your notes. But they are also available on page 29. So at least write a note to yourself to see page 29, and I would call it the reciprocal identities. So you know that these can be found on page 29. Okay, what is a reciprocal identity? A reciprocal identity is a flip-flop of the identity. So the sine of theta is equal to 1 divided by the cosecant of theta. So if you found, for example, the sine of 45 degrees, its answer would be the same as taking 1 divided by the cosine of 45 degrees. So these are reciprocals because the two sides are equivalent. A 1 over secant theta is equal to the cosine. Tangent is equal to 1 over cotangent. So these two match up, sine and cosecant. Cosine and secant match up. Tangent and cotangent match up. These other three are just the reciprocals of the first. So see how it's 1 over sine, 1 over cosine, and 1 over tangent. So these two trig functions are grouped together, tangent and cotangent. Cosine and secant are grouped together, and sine and cosecant are grouped together. And these are called the reciprocal, think of flipping, the reciprocal identities. So in this section, we're going to use the reciprocal identities to find information here. So what I like to do is I start by identifying what is given and what I'm trying to find. Okay, so here's what I know. Secant of theta, given that the cosine of theta is 2/3. Okay, so this would be my given information. And this information is what I'm trying to find. Use the reciprocal identities to find each function value. So I'm looking for the secant of theta. That's what I'm trying to find, given the cosine theta equals 2/3. And by the way, at this point, if you need to pause and copy down these examples, please do. So pause now, write the title and the directions, and then write down example A, and then we'll solve it. So I'm going to start by writing down what I'm trying to find. So I'm trying to find the secant of theta. And what I'm going to do is I'm going to use one of these trig functions based on what is given. So let's take a look at our reciprocal functions, the reciprocal identities. And we have originally secant, and we have a value for cosine. So we're looking for something that says secant and cosine in it both. Okay, so these are my two options. These are my secants and my cosines. But my original question says secant of theta equals. So let's take a look at it again. Secant theta equals. So I'm going to get rid of this secant of theta, and I'm going to replace it with its reciprocal, its equivalent. So let's go ahead and get rid of secant, and we're going to replace it with cosine theta. So we're going to leave this here, and I'm just going to write 1 over cosine theta. Now, what I know is the value of the cosine of theta. It's right here. You can see that the cosine of theta is 2/3. So I'm going to take out this cosine of theta, and I'm going to replace it with its 2/3. So I'm going to cross it out because, again, I'm going to be replacing it with its value 2/3. I'm just going to go ahead and rewrite it down below here. 1 over. Instead of cosine theta, I'm going to fill in 2/3. And again, this is going to end up being my secant. Let's go ahead and do the math. If you have a number divided by a fraction, what you actually do is you multiply by the reciprocal. So instead of 1 divided by 2/3, I can multiply by the reciprocal of 2/3. Multiply by the reciprocal. So instead of 2/3, I'm multiplying by 3 over 2, and 1 times 3 over 2 is 3 over 2. So the secant of theta equals 3 over 2. So example B, let's first start with what we're trying to find and then what we have given. So these are not always going to be fractions. Let's take a look at example B. Tangent of theta given the cotangent of theta is equal to -2/5. So at first I'm going to identify what I'm trying to find. Again, the direction says find each function value. So we're looking for the tangent of theta given that the cotangent of theta equals -2.5. So this is what's given. I'm going to start by writing out what I'm trying to find. I'm trying to find the tangent of theta. And what I want to do is I want to replace it with an equivalent that has cotangent in it. So I'm going to go back to my reciprocal identities and see which one has a tangent and a cotangent in it. You will see that there are two of them, but the one that I'm looking for is the one that starts with tangent and has cotangent in it on the other side of the equal sign. So I'm looking for the one here that starts with tangent but is the same as 1 over the cotangent. Now what I'm going to do is I'm going to use the information that's given, the fact that the cotangent of theta equals -2/5. So I have the cotangent of theta. I'm going to get rid of that, and I'm going to replace it with its value that's given. So I'm going to cross out cotangent theta, and I'm going to replace it with -2.5 because that's what it says it equals here. So I brought down tangent theta, I brought down the 1 divided by, and the only thing I've done so far is I got rid of this cotangent and I replaced it with the given value, which was -2.5. This is not a number divided by a fraction. This is a number divided by a decimal. So I'm going to go ahead and give my answer as a decimal by dividing 1 divided by -2.5 in the calculator. I brought down tangent theta, and the answer is -0.4. So tangent theta equals -0.4. So these are the reciprocal identities. I'm starting with given the cotangent, and I'm finding its equivalent if it was a tangent. I started with the cosine of 2/3 here, and I ended with its reciprocal, which was secant 3 over 2. So these are reciprocal identities. So go ahead and write this one down, pause if needed, and then we're going to start by writing what we're looking to find and what we're trying or what we're given. So go ahead and pause now if needed. So this is what we're trying to find, the cosine theta, and we're given the secant of theta. So again, I'm going to look back at those reciprocal identities. So I'm looking for cosine, and I'm given the secant. Cosine secant, cosine secant. But the one that I want to go with is the one that has the cosine not in the fraction. So that would be this one. So cosine theta is equivalent to 1 divided by the secant of theta. So let's see what we can replace here. We know that the secant of theta is equal to, in this example, -5 over 2. So what I can do is I can find secant theta, that's what this value is. I can cross it out and replace it with its numerical equivalent for this question. Obviously, this is not always going to be the value of secant. So this is a value of the secant in this case. So I can cross this out and I'll replace it with the -5 over 2. Okay, so I rewrote everything else, and I'm going to put in the -5 over 2 here. This one is similar to the first one that we did, where you're taking a number divided by a fraction. So in math, you never actually divide by a fraction. Instead, you multiply by the reciprocal of the number that is in the denominator. So instead of doing 1 divided by -5/2, I'm going to do 1 times, and then I'm going to do the reciprocal of this. So 5/2 would be 2/5. And again, this is multiply by reciprocal. And you can just kind of abbreviate. So let's go ahead and do that. And this is going to give us the cosine of theta. Well, 1 times -2/5 is just going to be -2/5. So our cosine theta equals -2/5. Next, we're going to figure out sines of functions of non-quadrant angles. So when we're talking about sines here, we're not talking about SINE, we're talking about positive versus negative. Go ahead and pause the video. You want to write down the directions and example A. Leave some space for B. We'll write that in a moment. So go ahead and write down example A and the directions. I'm going to draw out a coordinate plane to figure out what 74 degrees equals. So 74 degrees starts here at 0, rotates counterclockwise until you get to that 74-degree mark. If you go straight up and down, that would be 90. So 74 would be just a little bit less. This is an estimate of what it would look like. The important part about this question is figuring out what quadrant this angle sits in. This angle sits in quadrant 1. Now, the directions for this say determine the positive and negative signs of functions of these non-quadrant angles. So I'm going to use this chart, which is on page 30, and I'm going to decide what happens in quadrant 1. What is positive and what is negative. So if I were you, I would copy this chart again into your notes. It is on page 30, or just put see page 30 at least. So I'm looking for quadrant 1. That angle that I just found falls in quadrant 1. And I need to talk about what's happening with each one of these trig functions, sine, cosine, etc. So if you look at them, everything in quadrant 1 is going to be positive. So there are no positive or negative signs in quadrant 1. So you will write all are positive. We also need to somehow note that there were no negatives. So in quadrant 1, everything was positive. So that means for negatives, you can just write none. So example B is a negative angle, but we're never actually going to graph negative angles for now. So instead, find an angle that is coterminal to it by adding 360 degrees. So we're going to draw an angle that is 345 degrees. Start here at 0, rotate around counterclockwise. If you go straight up, that's 90, 180, 270, 360. We need something just a little bit less than 360. So maybe something like that. The important part is that we're looking at the quadrant that this angle sits in. And this angle sits in quadrant 4. So we're going to look up quadrant 4 on that plus and minus chart. So here's quadrant 4, and again, I highly recommend copying this chart into your notes so it's available. So let's look at quadrant 4. We're looking for positives first and then negatives. Cosine and secant are positive. Everything else is negative. So then that would leave sine, tangent, cotangent, and cosecant for negative. Here's our last one of the drawing picture, so go ahead and draw out your X and Y axis, and draw 178 degrees. Always start here at the initial side, rotating counterclockwise. 180 would be a line, so we're just a little bit shy of that. Just kind of an estimate. The idea here is that you're figuring out the quadrant, and this one is in quadrant 2. So we need to figure out what is positive and what is negative. So here's quadrant 2. Sine, cosecant are positive. All of the others are negative. So sine and cosecant positive in quadrant 2, everything else is negative. And there should always be a total of 6 trig functions. So if you don't have all 6, then look back and see what you're missing. In this section, we're identifying the quadrant of an angle. So copy down the problems, and you're going to need that table again with the plus and minuses. If you can't remember which of these symbols is greater than and less than, what you do is you take your left hand, you set it on your paper, and that would be your less than symbol. The other hand then is your greater than. And when we're talking about less than and greater than, look at the 0, 0, 0, 0. We're talking about 0. If I was to draw a number line and you gave me numbers that were less than 0, you would say that all of these numbers over here have something in common. They are all negative. Numbers then on the right would all be positive. Okay, so if we're looking for things that are greater than 0, those would be things that are positive. If we are looking for things that are less than 0, those would be things that are negative. And that's going to relate to this chart right here, positive and negative. So we're going to look at sine of theta. Remember, like Thanksgiving theta. The sine of theta is greater than 0. And then we're going to look at where the cosecant of theta is greater than 0. Let's start with sine. So go to sine. This is the sine column. And we're trying to figure out where the sine is positive. And it's positive right here in quadrant 1. And it's positive right here in quadrant 2. Let's look at cosecant. And we want to know, where is it greater than 0? Again, we're looking for positive. I'm going to label this. Both of these we're looking for positive, positive. Okay, so let's look up cosecant, and we also want to know where that's positive. Here it is, follow it over. Again, we're looking at quadrant 1 and quadrant 2. We are looking for the quadrant or possible quadrants of an angle that satisfies the given conditions. Well, look, this one's 1 and 2, this one's 1 and 2. So where are both of these conditions met? They are met in 1 and 2. They both have it in common. Cosine of theta is greater than 0. Remember, greater than means positive. Sine of theta greater than 0, positive. Let's look up cosine first. We're looking for where the cosine is positive. Quadrant 1, quadrant 4. Next, let's see where the sine of theta is greater than 0 or positive. Sine was quadrant 1 and quadrant 2. Now we're looking for where both conditions are met. So quadrant 1, and that's it. They only share quadrant 1. So they both have to have that condition met. And in this case, it's just quadrant 1. Here's your last one. Go ahead and pause if needed. And then let's get that one done. This time it says secant of theta is less than 0. So that means we're looking, according to what we wrote up here, less than 0 means we're looking at things that are negative. And again, this one's less than 0. One thing that your book likes to do is sometimes it will give you one of each. So just make sure you're paying attention to that as you're writing these out. Okay, so secant of theta is less than 0, which means negative. Let's look for secant. Looking for negative, it's going to be 2, and it's going to be 3. Next, we're looking up cosecant and looking at where it's negative. So here's cosecant 3 and 4. And these are quadrants that I'm talking about here. So look at what you have in common. Again, we're looking for where the conditions are met, and that would be quadrant 3. So this is the assignment set for this set of notes. Have a great day.